I am going to solve exercise 3C and question 9. So we're given this information. This is line 1, and then we're told line 2 goes through this point and is perpendicular. So the first thing I'm going to do is just rearrange this to look like y equals mx plus c, because if it's perpendicular, I'm going to need to know the gradient. So let's just rearrange. So I've got 5y equals negative 2x plus 10. So then y is negative 2/5 x plus 2. All right, so this is my equation for line 1. So what I'm being asked to do in part A is find the equation for part 2, right? So what I'm going to do is use so I know that my gradient is the inverse of this. So it's positive 5/2. Flip it upside down, change the sign. And I know it goes through this point. So I can use my wonderful equation, y minus y1 equals mx minus x1, because I've got a point and a slope. So y minus, I'm going to use this, so it's plus 6 equals mx minus, but it's plus 9 because it's negative 9. So then y equals 5/2 x plus 45/2, and then I'm going to minus 6 over here. So y equals 5/2 x plus 33 over 2. All right, so that is the equation of line 2. So that bit wasn't too bad at all. The second bit is where it gets a little bit awful. So part B, let's change color. So part B is asking me to find the area of the triangle. So what I've got is I've got point A, right? I'm given that as point A, and I'm told that it also goes through the origin. So AOB, okay? So this triangle goes through, or ABO, I think it says actually. Let's write that properly. ABO goes through the origin. So O is actually the origin. So the problem here is that we don't know B at the moment. So we do know that line 1 and line 2 intersect at B. So the first thing we need to do is find B, because that's going to help us. I'm going to draw this triangle in a minute, because that's sort of the tricky bit to try and picture it. But for now, let's try and find B. And if we're told that line 1 and line 2 intersect at point B, well, we just need to make these two equations equal each other, right? We've already got them in the right form, y equals. So what I get to do is just make them equal each other. I'm going to swap colors again. So this is going to be point B I'm finding. So I've got negative 2/5 x plus 2 equals 5/2 x plus 33 over 2. So what I'm going to do is I'm going to get my x's together and I'm going to get my numbers together. So I've got 2 minus 33 over 2 equals 5/2 x plus 2/5 x. You could have done it the other way around. I did it this way so I wouldn't end up with any negatives. Actually, maybe I'll just zoom out a bit and move that over here. All right, so then that means I end up with negative, what have I got? Oh, I've written the wrong thing. Anyway, so if we add this together, we end up with 29 over 10x, and this is what, 4 minus that, so negative, well, that doesn't sound right. What have I done there? I now can't find where I've done it. Anyway, so 2 minus 33, so that's 4 over 2. So 4 oh, that's what it is, negative 29 over 2. Okay, that makes sense. All right, so then all I'm doing is dividing that, and wonderfully, it comes out as negative 5. So that's a nice, easy answer for us. So what I now need to do is get y. I've got the x coordinate of b now, but I need to find the y coordinate. So I can put that into either of these equations. It really doesn't matter. But if y equals negative 2/5 x plus 2, you will find that that equals negative 4. So that means the coordinate of B is negative 5. Oh, it should be 5, negative 4, I think. No, it should be positive 4. Oh, this is positive 4. That's what I did wrong. Okay, so then let's just go back and insert that back up here. So we've got negative 5 and 4. So I'm just going to try and draw this for a minute because that's going to help us. This is a non-right angled triangle. Let's pretend that that is not a right angle, or I could draw it better because I know you're all laughing at me. Still looks like a right angle. Why am I so terrible at this? whatever. We're going to pretend that this is fine. Okay, so we've just done AB, right? This is going to be O. We know these 2 points. We know this point, but we do not have any right angles. So if we're asked for the area is clearly half times base times height. Now we can find the area of the length of the base. That's easy. That's just the length between A and B, and we know that. What we don't know is this height here. So I'm going to need to find a new coordinate here so I can get this length. So if that's the base, that's the height. The base is easy, so let's do that first. All right, let's just move over a bit. Okay, pick a new color. All right, so I want the length of AB. All right, so the length of AB is relatively easy because we have the 2 coordinates. So we've got, let's start with the y, let's start with the x's, who cares? -9 minus 5 squared plus -6 minus 4 squared, and that is all square rooted. So that means we've got -14. Oh, I've done that wrong. Let me think about what I've done. That should be plus, shouldn't it? Because it's minus -5. That's what I've done wrong. So this should be 16 plus 100. Square root that is just root 116. And we'll just leave it like that because there's no need to simplify it at this point. Now, the difficult thing we need to do is find point C. So what I'm going to do is I'm going to say that I know the equation of this line, right? Let's just rewrite that. Oh, we've already used that color. So AB, we know already, is y equals 5/2 x plus 33 over 2. All right, so we did that already over here. So that's AB, and I don't know OC, but what I do know is the gradient of OC, right? So OC's gradient, it's going to be perpendicular, isn't it? So instead of 2/5, instead of 5/2, it's -2/5. So that's nice. And I know a point. The point is 0, 0, right? So if I do y minus y1 equals mx minus x1, but x and y are both 0 here because this is a 0, 0 coordinate, right? So that means the equation of this line is just y equals -2/5 x, right? Because if I do minus y1 and minus x1, they're both 0, so who cares? They don't matter. So what I now do is I want to know when this line intersects with this line. So I'm going to make those 2 equations equal each other. So I have let's go up a bit so I don't run out of room. -5/2 x plus 33 over 2 equals this, -2/5 x. Why did I make that negative? That was stupid. All right, so these 2 things must equal each other. Okay, so then if I do 5/2 x plus 2/5 x equals -33 over 2, I'm running out of room, so I'm just going to quickly solve it here. So that means x is -165 over 29 if you solve all that out. And then I need the y coordinate, so I just put that back into here. -2/5 x times this means that y is going to be -2/5 of -165 over 29, and that gives us 66 over 29. So that means that the point of C is -165 over 29 and 66 over 29. Now, that is a horribly messy coordinate, but now I can find the distance between OC because that is the height of my triangle. So I'm going to use the point C and the point 0 to find my length. So again, let's do that. So I'm going to pick a new color. Let's pick this. Okay, so OC is going to equal the square root of, well, it's really just the square root of these 2 things added together, isn't it? Because I'm just subtracting 0 from them both. So 29, so that squared plus 66 over 29 squared, square root of all of that gives us a pretty ridiculous answer. It is 33 over root 29. That's pretty annoying. You may have got a decimal answer to that. The reason I'm writing it like this is because the answer is actually a whole number answer. And if I don't write it like this, I'm going to end up with an approximation, which will be pretty close, but probably not exactly accurate. So what I'm going to do now is say the area is half times base times height. So we've got 33 over root 29, which we just found. And we found over here before that the length of AB, where did it go? Oh, up here. The length of AB is root 116. So times root 116. And if you type all that into a calculator, you end up with 33. So it is 33 units squared. And that is the answer to question 9.